You know, I like how wavy this function is. Hey, what's this over here? Upgrade. I wonder what this does. Uh-oh, where'd the waves go? There must be a way to go back. Huh, there is.
So, what is an antiderivative? Well, an antiderivative is essentially undoing a derivative. It is the opposite of a derivative from a purely looking at functions standpoint. So what that entails is, let's say we have our original function right here, and then we were to take the derivative like that. I just have it set up in Desmos right here. The antiderivative would be going back to the original function, just like so. Now, there's a problem with antiderivatives, which is going to be the main focus of this. You see, many different functions can share different derivatives, and I'll show you why right here. Let's say I replace this 2 with a c, and then just add a slider right here for c. Notice how all that happens is the function goes up or it goes down, up, back down, you get the point. Now think about what a derivative is exactly. A derivative is looking at the instantaneous rate of change, or the slope at a singular point. That's grossly oversimplifying, but in essence, all of these functions right here, no matter where I move this c, are all going to have the exact same derivative. And that's because of the rules of derivatives in which we went several months going into, in which essentially stated that this c here will disappear. So the question is, how do you find that c? How do you know to turn this c into 2, as I had in the original equation? Well, that's where initial conditions come in. Now, of course, as I said previously, if we can't do it with numbers, then it's not worth our time. So let's make it worth our time. So we're given a question here. Evaluate the antiderivative of 3x squared plus 4x minus 5 in relation to x, where the resulting function passes through the points -1 and 4. This here is dealing with the example I had with Desmos about 5 seconds ago. Now, in this question, we're given an antiderivative, but we're also given this portion right here. This part right here is known as the initial condition, because for all of the antiderivatives in which exist for this one, whatever the heck c can be, there will only be, in most cases, one result in which passes through the point -1 and 4, and thus this here will allow us to find c. So our first step here is to take just the general antiderivative of this function, and we do that with the way in which what's taught to us, 2 plus 1 over 2 plus 1 plus 1 plus 1 over 1 plus 1. Gee, I wonder what that could be. 5x 0 plus 1, 0 plus 1. If you're reading this, then you probably know how to do this. Your results will be x cubed plus 2x squared minus 5x plus c. Now, what's c? So what we do is we take our initial condition right here and we plug them in for y and x. So 4 equals -1 cubed plus 2 multiplied by -1 squared minus etc. etc. And so with a little bit of math, we are able to solve for c. Then what we do is we just plug c right back into it, and therefore the answer is x cubed plus 2x squared minus 5x minus 2.